Hi, I'm Anna Hoffman from the SQL team. Welcome to this session. Before we start, I want to encourage you to follow us on Twitter at Azure SQL and at Azure SQL DB to stay up to date and use the hashtag Azure SQL to let us know what you're building. And now it's my pleasure to introduce this session where Ajay Jagannathan, a principal group program manager on the SQL team, will tell you all about Azure SQL, what to use when, as well as some of the latest capabilities. Take it away, Ajay.
Thank you, Anna. Hello, everyone. Excited that you are all here today to watch this session. So we'll cover a lot of topics about Azure SQL, and the three main areas I'll be talking about are first, Azure SQL offerings, where we'll go over different choices that you have in the cloud for SQL. The second, we'll talk about when to choose each of these deployment options, and also a couple of demos to show some of the new latest capabilities. And finally, we will end the session talking about recent updates that we have released for Azure SQL in the past 6 months. With that, let's get started with the first topic. So Azure SQL in the cloud on Microsoft Azure is a family of SQL deployment options. And let's walk through a few of these quickly. The first one is infrastructure as a service. So this is your good old SQL Server running on Azure virtual machines. This is the same SQL Server that you're used to using on an on-premise data center or in a hosted environment. And it gives you full control and flexibility of the environment because you choose everything from the OS level up on what needs to be deployed. However, if you want a fully managed service for SQL, you have two choices. The first one is Azure SQL Managed Instance. This is equivalent to SQL Server Engine on-premise, the full service with all the surface area capabilities, but running in your network, so it gives you that private security. Or you have a database as a service option where you can just provision a single database with the resources you need and either move applications or build new applications on top of that. And we will look at some more capabilities of each of these in the upcoming slides. Another point I want to highlight is SQL database also offers serverless and hyperscale options, so you can pick the right tier based on your workload requirements. No matter what deployment option you pick, some of the benefits of Azure SQL is the familiarity. It is the same SQL Server engine that runs on the edge, on premises, or in a hosted environment, or on Azure. It's built on the same code base. In fact, our engineering systems for SQL is a single code base, and then the code is checked and deployed to various release vehicles. And you get the same surface area because of that with T-SQL or various client drivers such as .NET, Java, Ruby, etc. Tools. Even here, you can use your existing tools such as SSMS or Azure Data Studio to interact with Azure SQL, just like you would your on-premise SQL. And you can also build and deploy applications using Visual Studio or SSDT like you would. And finally, you get flexibility in terms of the deployment platform, as we discussed above, or even the development platform, whether you are a Unix user or you want to develop on Linux or open source or Mac or Windows or containers. So it gives you the complete range of options. Before we deep dive into various options, I want to quickly share this recent study done by GigaOM, which is an analyst firm, and the detailed study is available in the link below. As you can see on this chart, whether you pick the PaaS deployment option on the left or the IaaS option on the right, in both cases, you get significant price per benefits on Azure only, where you can see up to 84 to 86% savings, just whether you're getting started on Azure or even running production workloads. This includes Azure only benefits such as Azure Hybrid Benefit, which waives your license cost for SQL Server, as well as you can also leverage 3-year reservations for additional benefit savings. And more details are available in the link below. So now let's look at what to choose, the different deployment options, and when is the right time to pick the one. So the different workloads that you see coming to Azure are one, existing applications which are already running on SQL Server. These are basically applications you want to migrate to the cloud. The second one is you want to modernize your applications on the cloud. Basically, you take your existing applications and then build in some new features such as ML services or Power BI or connect with other services in the Azure ecosystem. Or the third option is if you're starting in the cloud as a native cloud-born application, that's also a scenario where we see a lot of customers building apps on top of Azure SQL. But before you start, there are two main questions you need to answer yourself, which will help you in the decision making of which offering is right for you. The first one is control. So here you try to understand and define how much control you want for the environment, whether you want to control it completely yourself or you want it to be a fully managed option. If the second option is capabilities, so various deployment options of Azure SQL provide different capabilities. So that also becomes a very critical point when you make your decision. So let's look at how this plays out. So if you want to pick your own and manage your own environment, and control everything inside the environment, such as the operating system version, the version of SQL Server, if you want to control your downtime for patching or upgrades, if you want to host your application inside the same VM as SQL, if you want to manage backups, security, HADR, etc., then you would pick SQL Server on Azure virtual machines, as this gives you the full range of flexibility, but running on the Azure infrastructure. So you don't have to worry about hardware and capital expenses in terms of growth of your business. However, if you want a fully managed option, there are two choices. Here, the first one is fully managed SQL Server Engine as a Service. Here, you would pick this option if you still want SQL Server instance level capabilities, some of which are listed here, such as cross-database transactions, link servers, CLR, and you name it. And in this case, you would pick Azure SQL Managed Instance, which gives you near 100% compatibility with SQL Server Engine on premises, and you can use databases from as far back as SQL 2008 with full compatibility guarantees. However, if you don't want a full SQL Server instance and you just want to get started with a database or more applications which just need database level features, you would just pick Azure SQL Database. And as I mentioned earlier, here we have multiple options such as general purpose or business critical tiers, depending on your workload, throughput, and latency requirements. We also have serverless or hyperscale, depending on whether you want to save costs or if you want to grow at scale. And we will talk about that later. Now that you know all the different options, how do you get started? So whether you are building applications on edge, on the cloud, or on premises, as I mentioned, the tool set and the programming surface area gives you the same set of options. You can pick your favorite development language as choice, such as C# or Java or any of the new tools like Python, Node, etc. And you can pick your favorite development platform, whether it's Mac, Linux, or Windows. And you can get started with the API from there. The link below gives, picking your platform, it gives you some guidance on how to get started. And you can also integrate this as part of your CI/CD pipeline. We have a GitHub repo, and the link is on the top, which you can refer to on how to deploy and use Azure SQL in your CI/CD pipeline. And in terms of workloads, SQL has been in the industry for more than 25 years. We have customers using SQL for all kinds of workloads in any industry, whether it's government or healthcare or finance or insurance, you name it. So, because of the variety of data formats that SQL supports built into a single engine, you can run operational transactions such as online transaction processing, which is your crux of your insert, update, deletes. You can do hybrid analytics using HTAP, or you can use operational data reporting using some of the features. And as you can see here, it's not just relational data types. We also support other types such as JSON if you want, document store, or if you want to do relationships or recommendations, etc., or CRM, etc., you can use Graph. If you're doing mapping or geospatial applications, you can use spatial data types. And if you want really high, low latency, high throughput systems where we have a lot of customers doing like online gaming, online betting, etc., they use some of the latest capabilities such as lock-free in-memory tables and doing real-time analytics using column store. And all of this are built into the same engine. You don't have to add any features or install any extensions. In some cases, it's as simple as creating an index and you're good to go from there. But no matter what workload you have or what data store you pick, security is most important, especially customers who are worried about GDPR or privacy, etc. And SQL has an industry-leading portfolio for security, for data protection, all the way from at rest, in use, and in transit. With always encrypted, you can bring your own keys and have it in Key Vault to protect your data, and only your business users will have access to the data. And other layers of security offer you granular controls such as data masking, row-level security, etc. And we also integrate well with Azure Active Directory and various other security features. More details in the link at the bottom that you can learn about how you can leverage the portfolio of features in Azure SQL for various workloads. Now let's look at some of our latest offerings. The first one is serverless. There is a session on serverless which will go in more detail. Here I'll highlight a couple of the key value of serverless offering. So one of the common scenarios is dev test workloads. As you're building your applications, you don't know what the workload requirements are. And also in a dev test environment, you don't need a provisioned compute where you pay for the service even if you're not using 24/7. So serverless is a great choice there, where you only pay when you use the service, which is per second billing. It's the lowest in industry in billing granularity. And it's also ideal for applications which are used only sporadically, such as, let's say, performance review applications or HR apps, which may not run daily, but let's say once a year or twice a year, etc. Or even other intermittent workloads which run, let's say, once a quarter, or weekend processing or year-end processing. As you can see in the chart on the right, serverless, you specify a range of compute you want for your instance. In this example, you have 1 core to 4 cores, and the service will automatically scale up and down based on your usage. And you are, even if you specify a max vCore of 4, you will not be billed for 4 vCore, you'll only be billed for what it's using. And then there is something called auto pause delay, which is basically you define as how much time is the idle time before the serverless goes away. So in this case, if you say 1 hour is your auto pause delay, when we detect 1 hour of idle time, as in no workload is running, we will automatically pause the compute, take a backup of your database, and then release the compute. So at that point, you're no longer paying for the compute and your database is backed up, so you're only paying for the storage. If your workload comes back again, we will automatically restart the compute. We will persist all your original settings, so we restart it back, attach your database, and your application starts running again. So you will have a very seamless integration in this with this experience. And more details on all the capabilities of serverless will be in the other session. And our latest and greatest offering is hyperscale. Think of hyperscale as future-proofing your business. You can start very small with a very small compute as low as 2 cores and go up to 80 cores. And same way with database, you can start with a few gigabytes and go up to 100 terabytes. As you can see in the hyperscale architecture on the left, it is really designed for unlimited scale because we have completely separated the compute and storage with multiple layers of caching. Your actual databases reside in the remote data storage at the bottom, and it's fully backed by a covered 100% cache by the page servers. And then each compute has its own cache. Because the compute is separated from the storage, creating a new compute, secondary compute replica is a matter of few seconds or minutes. At the same time, scaling up a single compute, let's say you start with 2 vCores and you want to go up to a higher number of cores, it's just a matter of creating a new compute which higher power and then attaching the same databases to that. So there is no size of data movements. You will also notice the log service is separated as a microservice. So this provides infinite log stream and also serves all the replicas. So there is no size of data movement between all the replicas because they share the same page servers, which means all the data that is written to in the primary is immediately available for reads on the secondary through the log service. So you can do near real-time analytics with read scale out. And this architecture also enables offloading some of the expensive maintenance operations such as backups, which can be done now on the page servers. using Azure Blob file snapshot technology. So your backups is almost near instant. It's mostly a metadata operation. Likewise, the restore is the reverse. The only time spent is creating the actual compute on the page servers when you do the restore. Likewise, checkpoints can also be offloaded. So your user compute layer is only serving the application workload and it's not impacted by high activity happening on the maintenance side. Read more about hyperscale at the link below, and this will really help you future-proof your business when you're starting small and you want to grow to unlimited scale. So with that, let me quickly show you a couple of demos. The first one I will show is how you can do high-speed ingestion, simulating an IoT device scenario. And the second one is how you can use read scale out with hyperscale and SQL graph to do some recommendations, all built within the same SQL Server service. So let me switch to my demo scenario. So as you can see in the browser here, this is in our online documentation. This is a very common IoT reference architecture where you have data coming from various devices on the edge flowing into the cloud to your stream analytics service, which is which is processing all the data and sending it to either warm or cold path. So one of the requirements for warm path is being able to support low latency, high throughput ingestion, as well as near real-time analytics. And Azure SQL meets all these requirements with some of the features I talked about earlier, such as in-memory OLTP and column store, etc. So we will be using this architecture for the demo. And my colleague Davide has published a GitHub repo, which is available for download for free, where you can deploy the same architecture by downloading this sample and installing it. Once you download and install it, you can see in my dashboard portal here, I have various resources automatically created. I have my client generators, which are simulating the IoT devices. I have my event hub, which is receiving the data coming from those devices and sending it to my stream analytics. And stream analytics is finally landing the data in my database in hyperscale, which is where we will run our queries and do some of those demos. And to show you how the hyperscale environment is, as you can see here, I've been running the workload for past several hours, and the database has grown to 8 terabytes, and it'll keep growing automatically. You don't have to worry about it as more data comes in. And as you can see from the capabilities of hyperscale here itself in the configuration blade, you have just 2 sliders to easily scale up and scale down your compute. So right now I'm using 16 cores of CPU and 1 read replica. If at any given time I want to increase the compute power of this instance, it's just a matter of doing this through the portal or through APIs, and I can bump it up to as much as I want, and then the compute will immediately scale up without affecting your data, and then attaching your databases to the new specs as soon as it's ready. So I've already done that, and my IoT workload is running here. As you can see, I'm capturing few metrics. Let's take a quick look at these. These are all my clients sending data to my from my devices at about 2 MB per second. This translates to about, as you can see in my stream analytics output, around 600,000 events per minute, which amounts to 1 billion rows per day. Just digest the number per minute. And even at that speed, you can see the compute utilization on my primary for my Azure SQL hyperscale is less than 15%. So SQL is able to handle that rate of ingestion without much impact to the resources itself. So now that you're seeing how the active ingestion is happening, while this hot data is coming in, let's go and run some analytics on this and see how it looks like. So here I'm connected to the same database. Here, the first one is a read-write connection, as you can see, and we will run a query against the hot data. I'm returning top 50 rows for a specific device from the past hour. Since the data is already cached in local compute, as I mentioned, this query should run instantaneously. And as you can see, it finished in less than a second. Now, a lot of customers want to separate their ingestion workload or transactional workload from their analytic workload because of sensitivity. So we can actually use read replica here, just like you would on premises. You can connect using app intent read only, which is what I have done here. And you can see that I'm in my read only instance because the same data is shared through the page servers to all replicas. The data should be also, the hot data should be available here in near instant time. So this query should also run almost instantaneously on my secondary replica, as you can see here. Now, I also mentioned that you can run not just regular SQL queries, but you can also run non-relational data like graph, which is built into the same engine. Here I have a graph query from a million songs database, which is basically all the listeners who are listening to various songs. It keeps track of that and builds relationship. And this query uses some of the latest capabilities of graph, such as shortest path, to identify which songs are the most influential. So if I run this query on the same database while the IoT is running, I would be able to do that without impacting the primary compute, because this is running on the secondary. And you can see that the query runs almost instantaneously and gets me the results. So that's the demo for showing a couple of different capabilities. But there's obviously a mature service. You can run all kinds of workloads, as I shared earlier. Now let me switch back to my presentation and let's talk about recent updates in the service. Azure SQL as a service has been in the market for more than 10 years. You can keep up to date on the link above with Azure updates, where we post every announcement that comes. But as you can see in this slide, we are continuously innovating the platform for the various deployment options, whether it's platform level capabilities such as DR and networking and security, or surface area capabilities such as change tracking and accelerated database recoveries and authentication, etc. We are also enabled private link recently, where you can connect securely through a private endpoint to Azure SQL without having to go through public internet. So you can connect through VPN or express route. And then we continue to invest in virtual machines, where we now have a free DR replica if you are running on the cloud. Also invested in migration tools, where you can do application assessments, database assessments, and understand the compatibility before you migrate. So with that, I'll conclude my session with leaving you with some resources here, which will help you get started. And the main message I want to land is, no matter what workload you pick, what data storage you want, Azure SQL has capabilities that will meet your requirements. And from there, let's move on to Q&A. Thank you.
Thanks, Ajay. That was an awesome session. I wanted to briefly call out that there will be a session on Azure SQL Database Serverless in about 3 hours. So if you want to learn more, be sure to tune in to that. So now we're going to switch over to Q&A. And the first question we have for you, Ajay, is, does managed SQL provide disaster recovery?
That's a good question. So with managed instance, there are two different options. One is high availability, which is already built in. If you, for example, if you pick the business critical tier, every primary replica gives you 3 additional secondary replicas without having to pay extra cost. So that is in your local data region, which provides high availability. DR is also available. You can spin up a secondary managed instance in any other Azure region of your choice. And then you can set up what's called failover groups between the two, and that acts as your DR scenario, and it can also be used for read scale out.
Great. Thanks, Ajay. Another question is it possible to use Azure SQL as the third node in an always-on architecture?
That's a great question. That's something we don't have today because of version differences between SQL Server on-premise and Azure SQL, which is always running latest and greatest. But look forward to hearing something on this in the future, how you can build hybrid capabilities. Customers are actually using other technologies like replication and snapshots, etc., to achieve the same thing.
Awesome, thanks. The next question is, How long is the latency to restart a paused or released serverless SQL server? Will my users experience timeouts until it hydrates back?
That's a great question. So we are continuously improving the startup time for serverless. So right now it's around 30 seconds to 45 seconds. It really depends. But in most cases, if you have application timeouts set to between 30 and 60 seconds, you will not even see a disconnect. But as a best practice, even outside of serverless, we always recommend customers to have retry logic. We do have public documentation on how to build resilient applications for intermittent disconnects. So if you have that retry logic built in, you will not have any negative user experience. It will automatically retry and connect. But we are working on the platform side also to lower down the startup time.
Yeah, thanks, Ajay. And I think that's a great call out. We are always encouraging people to have retry logic in their applications. And I apologize if you're hearing some echo on my part. Okay, the next question is, when will long-term backup for managed instance be available?
That's a good question. That's right around the corner. Look forward to hearing more about that in the next few weeks.
Awesome, thanks. Let's see. This one says, are there any gotchas when migrating to an Azure database instance? I'm guessing they mean managed instance, from on-prem to an Azure managed instance. Are there any gotchas?
So I'll answer this question generically. No matter what target you pick in Azure SQL, the recommendation I would say is to use our database migration tools. It's free. You can go to datamigration.microsoft.com. We have a full playbook there on how to use these tools. You can do application assessments as well as database assessments for what different targets, and it'll tell you all the features you're using and any potential issues you may have, whether it's behavioral or breaking changes, etc., on how to address them so that you have a smooth migration experience.
Okay, let's do one or two more quick questions. The first is, which offerings of SQL support TDE?
So all of it. So in Azure, TDE is on by default with service managed keys, but you can also bring your own keys if you want to manage the encryption and decryption with your keys. So both options are available. If you create a database in the cloud and if you don't bring your keys, we will encrypt it by default.
Awesome. Thanks, Ajay. And the last question we're going to have is, when do we think GeoDR capabilities will come to hyperscale?
Again, that's also a work in progress. So look forward to seeing some announcements shortly.
Awesome. Thanks so much, Ajay. So we're going to put back up the slides so you all can see the resources. A few people asked for that. And as we close out, I want to remind you, one, that there's a session on serverless where Morgan Oslake will go deeper into how it works and what patterns it's good for. And to follow us on Azure SQL and Azure SQL DB if you want to stay up to date. And with that, we hope you have a wonderful rest of build wherever you are. Thank you.
Thank you, folks, and happy to see you folks join this session. A ton of resources, and as you see, Azure SQL is available for you to try out for different workloads. It's the same SQL Server you're used to and existing tools. You can get started easily with the resources here, and looking forward for seeing you folks using this. Thank you again.